Hello everyone, welcome back to the channel. So with this video, we will start a new series and in which we will learn about Pytorch library and basically we will start with basics of Pytorch and then we will go to the various transformation techniques with Pytorch tensors and then we will learn about N module and see like how different neural network architectures implemented in PyTorch, and then at the end we will implement our own transformer model. Okay, so tensors in simple layman terms you can think of it contains data with some uh, along with its linear operations. Okay, and though if we look at mathematical definition that will be a bit complex and out of scope for this video. But I will add some links where you can refer it for more details. Okay. So in PyTorch, we have two types of tensors. One is float and another one is int, which is integer. And by precision, you can divide them into four categories like 64-bit tensor, 32-bit tensor, 16-bit tensor, and 8-bit tensors. Okay, and 16 and 8-bit tensors are mainly useful when we do model quantizations. Okay, like we need to reduce the model size to fit a particular hardware requirement. Okay, we will see these details when we build a model and see like how we can quantize it. In this video we will learn what are the types and how we can create basic tensor and how we can convert in various type of tensors. Okay, so let us dive in and see how we can do that. So let us first import um, torch library. So we can simply say import torch. And to get information about any particular type, we can simply use finfo and iinfo. Finfo is for float information and iinfo is simply for integer information. So let us do that first. Use torch dot finfo and we simply pass what is the type we want to. We can simply say torch dot say float 16. So it will give us information about float 16. So let us run and see it. So you see it does like resolution 0.001, minimum value you can use is 65,504 and so on. The same thing you can do with integer as well. So for example, if I want to talk, I want to get information about int 8, it will tell us about integer 8. Okay, so let us run and see it. So you see minimum value is minus 128, maximum is 127 and so on. Same thing you can do with other data types that you want to know about. Okay, next let us talk about how tensors are created. Okay, so there is two conventions that are generally used. One is using torch.Tensor or another one is using torch dot this tensor with a small t. Okay, so let us see how they are different in that sense. So let us say we want to create a tensor. So let us comment this out. Let us say we want to create a tensor using torch dot capital T tensor. Okay, let us see what it gives us. And now let us print tensor and let us print tensor dot type. Okay, and let us run and see it. So this is what I wrote here. Like when we create, okay, we need this parenthesis as well. So let us run again. So you see here. So when we use this capital T, by default, it assigns it as a float tensor. Okay, the tensor type will be always float tensor. Even if I will add more values here, like 1, 2, 3, those will be float values. Okay, the default type is float tensor type. Okay, so let us run and see it. You see, they are not like integer because we entered integer. And if we try to change its type using d type, it is not allowed. Okay, so we cannot say torch dot int 32. Okay, it will complain because this is not correct way of doing it. So let us run and see it. So it says like it is not allowed. So keyword because this is mainly equal this is mainly equivalent to using torch.float tensor directly. Okay, so that's why it is handy to use torch.Tensor, where you can specify the d type what you want to have the data type. So let us see how we can do it. So we'll simply copy it, comment this out, and use small t. Okay, and then it will work fine. Won't complain anything. Okay, you see, it is integer tensor, which is 32. Okay, I hope that is clear. And so as I said, by default, the tensor data type is automatically assigned, but you can force it using d type as we have seen. And the default is float 32 and int 64. For example, if I will say this, but remember that this will always be a float tensor. Okay, the default data types which are automatically assigned, that is with this torch.Tensor is with a small t. Okay, so if in this case it will be int uh, int 64. Okay, because all these are integers. So let us run and see it. So you see long tensor, which is nothing but int 64. Okay, here you can see. And if I will add float like 1.1, 1.1 and so on, now it will be float 32. Okay, so let us run and see it. You see it is float tensor, which is nothing but your float 32. Okay, I hope that is clear. And so of course you can change it using d type as we have done it earlier. Like you can say it to be d type is equal to int, sorry, torch dot int 16. Okay, now it will try to change everything in the int and represent it as a int 16. Okay, so let us run. So it says something like um, deprecating an integer is required, got type float, implicit conversion to integer using got in, da 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 da. So there is some new methods to do this conversion. So we will see in later videos what are those various conventions to be used. Okay, next let us see like how we can change the d type after we already created a tensor. Okay, so let us comment it, and let us say we have created a tensor is equal to, let us say torch dot tensor. Let us say we have 1 2 3 4 5, and let us say, so it will create like in 64. Okay, so let us um print the tensor, and also let us print the tensor type. Okay, now let us run and see it. It will be in 64 because it will automatically detect it, and it will say long tensor. Okay, now let us say we want to change it in later part of the code. So we can simply use tensor.type. Okay, so we can simply say tensor with new type equal to tensor dot type, and we can simply use the torch dot whatever type we want it. We can simply say int 16. Now it will be converted to int 16. Okay. No, we cannot use int 16, but we can use um let us say we need to use these tensor types. For example, if you want to use int 16, we can say sort tensor. Okay, we can simply say short tensor. So for this conversion, you always need to use tensor type, not directly the d type. Okay, so now this type will be int 16. Okay, so let us print this. Also, let us print the type. So let us run and see it. Now you see, it was earlier long tensor and we converted it to short tensor, which is nothing but the type is int 16. Also, we can directly use this this method where I mean you can use also this string convention where instead of using this torch.sort tensor, you can pass here the string. Okay, this is simply when you don't want to import torch, like you already have it, like you already imported components all you need, and you don't want to import torch that will actually load all the components of torch library. So in that sense, if you need it to be more optimal way of importing, you can do that as well. So in that case, it will be helpful. It will do the same thing as it was doing earlier. Okay, so you see that works as well. Also, you can convert using this tensor dot d type, what you want to convert. For example, I can directly use here, instead of using this, I can directly use here tensor dot. So what we have here is simply, we need to look at it. It is short. Okay, so we can simply use this convention to convert it into sort sort integer. Okay, so that is simply, we can call that function here. Okay, that will do the same thing as well. So if we run it, we will see here it will do the same thing. Okay, so I hope these things are clear, like what various data types we have in PyTorch and how we can create a tensor, and then how we can convert it in various types whenever we need it. Okay, so in this video, we will stop here. In the next video, we will learn about some operations on tensor, like what are the simple transformations we can use, and what are the various mathematical operations we can do, and so on. Okay, so thanks for watching. Bye for now. Take care. See you in the next.